Okay, let's do a quick recap. It's been a long gap since the last class. So today the topic is going to be the difference between map versus flat map. Before even understanding that, I want to do a quick recap. So we know what is collections versus what is streams. Always remember that collections are mainly about the storage. So when you want to represent a group of objects into a single entity, collections. Okay? And when you want to process the objects that is already stored in a collection or in an array, right, then you can go for streams concepts. Streams are only used to process the data or to perform some kind of computations, a mathematical operations, computations I can say directly, right? And for the iteration collections, you have to do it by yourself. It is called as external iteration. For the streams, the internal, I mean, the iteration will be taken care internally. And look at this third point. You can add and remove elements from the collection. So collection is just like a data source, isn't it? It's like a data source. So you always have an option to add an element and to remove an element. But streams are not like that, because streams are like, you use the data source and you produce the stream of values. So once the stream of values are generated, so you won't be having any option to add an element. So you always need to deal with the data that is already there. So you're going to process the data. So it talks about the processing, not about the adding or removing the data, right? So collections can be traversed multiple times. I mean, it talks about the iteration. You can you can use a for loop, right? And you can run the collections any number of times. But streams are not like that. It can be traversable only once. Remember this point, because we have discussed these things already with an example in the previous session. Because once you are traversing by using streams, it is said to be consumed. Again, if you are trying to perform the traversal, you will get an exception, right? Collections are eagerly constructed, just like a pen drive. So you store the data completely, right? Data will be stored completely. DVD and CDs, all the data are stored completely. But streams are lazily constructed. Why lazily means? I have given you an example like Netflix. Okay, so when you're watching a movie, the movie won't get downloaded at a once. So it gets downloaded on demand, right? So you will be watching the movie, and the 15 minutes of movie may get downloaded in an advance. It is not necessary that the Netflix has to download the complete movie so that you can watch comfortably. So in the both the cases, it works, right? On demand things. So there are a lot of benefits for this on demand streaming. So streams are just like that, right? And you have stream method. So this is a very important method. It is going to convert the collection object or the array object. No, it is going to convert the collection object into the stream. And it is return type is always going to produce the stream of elements, right? So we know what is filter method for filtering purpose, and you know what is map method. Map method is for transformation, right? And working with streams. How can we work with the stream? So remember these three points. So you need a data source and followed by a chain of intermediate operations that is going to form a stream pipeline. There should be at least one terminal operation to execute the stream pipeline and produce the desired result, right? So there is a lot of discussion happened on intermediate and the terminal operations, and the examples are like these are the typical examples for intermediate operations, and you have the examples for the terminal operations, right? So difference, now today the topic is going to be difference between the map and the flat map. So you know what is map already, but there is a problem with the map. What problem you are going to face with the map, we will understand that with the simple example, right? For example, when you are dealing with a collection of objects, let us say that you have three elements in the form of integers 1, 2, 3, right? So this is what the data source. So you can store this element in like in any form of a collection object like array list or linked list, whatever it is. This is a typical data source. And whenever you are working with the streams, so it is important to convert the data source into the stream by using the stream method, isn't it? So the moment you do this, The moment you use the dot operator followed by the stream method, so everything is going to get converted into the stream, right? A stream will be created and the values will be pipelined, right? 3 to 1. A stream is created. So after converting this to stream, you can use a pipeline of intermediate operations. A lot of intermediate operations. You can pipeline it together, right? For our example, I want to work on the map, because we are discussing about map versus flat map. My actual requirement is I want to use the map method, right? So I will use the dot map method, right? My map method typically accepts the function as a parameter. So the typical lambda expression could be like this. So I accept the element and I want to perform a kind of mathematical operation which should be like this, right? The input is in the form of I and the output is going to be produced in the form of I plus I, right? Having said this, so when the input is accepted, the 1 gets converted to 1 plus 1, which is what? 2. Processing, okay? And again the 2, right, 2 will be accepted as an input and it will be returned as 4, because that is how the lambda expression is given, right? The last number is what? 3. 3 is going to get accepted as an input and 3 is going to get transformed, because our transformation logic is what? I arrow token I plus I, which means the input will be doubled, right? 3 plus 3 is going to be 6. So when you observe this pattern, so the kind of transformation, so one element is getting transformed, but if you observe one thing, this is dealing with a simple collection, right? This collection is called as a what? Simple collection. It's not a complicated collection. Simple collection in the sense, when I say a simple collection, so the values are straightforwarded, right? So it could be like this, guys. It could be like what? It could be like this. So list of integer. You are dealing with a simple collection. List of integer, right? And you have like you can take any variable name like numbers, right? And you can assign this like arrays dot as list. Okay, there is a method in the arrays, so where you can place the values directly without having to use the add method. This is how you can add the elements, so by using the list interface, right? This collection, this data structure is a simple data structure, right? So transformation has happened. After the transformation, and you have an option to do what? Either print the output in the console by using the for each method, terminal operation. We have been discussing things for a long time. Terminal operation, which is going to accept a consumer, okay, which is going to accept what? Which is going to accept a consumer, right? And you can accept the input, and you can use system.out.println, or you can print the same value. So this is how the map method is just taking care about the transformation. And you need to make one observation here. The observation 1 is very important, okay? The observation 1, for each and every input, right? For single input value, map is going to produce what? A single output. Definitely, if you are saying that you are passing 3 elements as an input, definitely the output is going to be the 3 elements. It is going to return the 3 elements as an output. There will be no change, okay? The input values are directly equal to the output values or the return values. First point, right? And having said this, and you can also make second observation, which is what? It is doing 1-to-1 mapping. 1-to-1 mapping. Second observation, very important. First observation is for singles input value, right? So this is the input. 1 is an input, 2 is an input, 3 is an input. You are getting the single output, which is what? 2 and 4 and 6. Very much straightforward, isn't it? Again, the second point is going to be what? It is called as what? 1-to-1 mapping, right? So for one object, the one object is going to one object is going to be transformed, right? And the number of if you see the input values is going to be same as output values, right? So they are also saying that it is just performing the mapping. It is performing. Map method is performing the mapping only. Mapping. Okay. So after this, when you see it is going to accept the function as an input, because the lambda expression is very much expressive. It is a function. So input type can be anything, output type can be anything. But the map method is going to return again the stream of values. Okay, so the transformed values are what? 2, 4 and 6, isn't it? So this is going to be like stream of values. Stream of values in the sense 2, 4, 6. These are the transformed values because this is the return type of the map. Okay, and again this 246 gets pipelined, right? What I'm doing, 246 is going to get pipelined again, and it gets consumed by the for each method, which is a terminal operation. It's going to get displayed in the console, right? So from here, every value stream is going to return the stream of values, which is what? 1, 2, 3, right? And map method is going to return the stream of values once again, 2, 4, 6. Okay, if you see, these values are transformed completely, but still the output is what? Stream itself. Both the outputs are what? They are what? Stream itself. Both the outputs are stream type itself, but the values are transformed. How the values are transformed? For 3 inputs, you got 3 outputs in a different way. Okay, so computations has happened, but the count is the same, isn't it? Right? So you must observe here, it is going to what it is doing, what stream is producing a stream of values, and again if you are using map is going to accept the function as an argument, and it is going to transform the values, and again that transformed value is of what type? Stream type, stream of values, right? So once this stream of values are produced, it is very simple for the for each loop to process this, because why it is going to be simple? Right, 2 is going to be a stream of one of the stream of values. It will be accepted and printed, and the 4 is going to be one of the stream values. Okay, each and every value inside the stream will get accepted by the for each method to get displayed in the console, right? Now we need to make an observation. See, let me write this in the code, right? So list of integer integer equal to I want to take the name as numbers arrays dot as list. So this as list method is one of the methods in the arrays. You can use this to add the values directly instead of right. You can avoid using the add method over and over again. So values are added to these numbers directly, 1, 2, 3. Right. After this, you want to perform the mapping, right? Numbers dot convert the data source into the stream, right? Dot, and followed by what is the transformation? We are going to use the map to perform the transformation, followed by you will use the for each loop dot for each loop. The for each loop is for each method, I can say it is not a loop, it is a method. It is a terminal operation, right? Sum dot out dot println. Right? So maybe thinking why we have been discussing, which has been already discussed in the previous section. Okay, now we will understand the difference. So this is a simple collection, 2, 4, 6. In future, you will be dealing with a complicated collection. When I say complicated collection, so there is a lot of difference between the simple and the complicated. So how the complicated collection looks like? For example, you have a collection object. So my collection, one of the collection objects has has 2 numbers. So 1, 2. I have second collection object. This collection objects has again 2 numbers, 2, 4, and I have the third collection object, right? This is my third collection object. My third collection object again has 2 numbers, which is what? 3, 4, right? So let us say that this is the C1, and this is C2, and this is going to be the C3 sequentially if you go, right? So these are the individual collection objects, right? And I want to add this individual collection object to another collection object, which is a complex collection object, right? So if I want to do that, I want to take a list. My list is going to accept the generic type as a complex collection, list of integers, nested list, I can say. It's not a simple collection. Okay, this parameter is going to accept a complex collection. This is going to be what? Complex collection. By using this complex collection, I want to add these three individuals collections, arrays dot as list. Arrays dot what? As list. Right? And by using this as list method, I will be adding the simple collections individually, like C1, C2, C3. Okay. So unlike in the previous collection is very simple. Directly, it is a very simple collection. You have three values, but here you are creating three simple collections, which are C1 and C2 and C3, and you are taking another collection object to add these three individual collections as a single entity. C1, C2, C3 is getting added into another collection, which is what? Complex collection. Complex collection. Right? So when you are dealing with the complex collection, you will face a problem to perform the transformation. What you want to do actually, you want to do the same. If you want to apply the same transformation logic like we have applied before, what is the transformation logic for the map and for the previous collection that we have applied? So you have taken a map method, isn't it? You have taken a map method. This map method is going to accept I, and the transformation logic is going to be I plus I. Right? But you cannot use this towards this complex collection. Why you cannot use this? We are going to see that now briefly. Okay. So now let me remove this. Let me create a complex collection quickly. Okay. So you have the list of values, guys. Okay. You want to deal with a list of three independent collections. So let me take the list of integer, right? So L1 equal to arrays dot as list. Okay, this is going to accept the typically a kind of three numbers I can take 1, 2, 3, right? And I want to take 4 more simple collections or 3 more simple collections. So let me take 4 more simple collections. This is L2, this is L3, this is L4. Okay, why this is simple? Because the generic type is integer, which means it is not even a complex. So directly you can add the integer values. So integer type, generic type is because integer, right? So here the complex is 2, 4, 6, right? And here 1, 1, 2, something like this. Then I want to do it like 5, 4, 6. Okay? So 4 simple collections. I want to add this object. I want to consider this object, each and every reference variable, as an independent object. I want to add it to a complex collection. My complex collection is going to accept this as the parameter. So my complex collection is list of integer type, right? So complex equal to arrays dot as list. I want to add the independent collections L1, L2, L3, and L4. L1 comma L2 comma L3 comma L4, right? I want to apply the same transformation logic. What is my requirement is? My requirement is I have a requirement like accept each and every value and perform and double the value. Right? You have 1, so 1 should be 2, 2 should be 4, 3 should be 6, 4 should be 8, again 2 should be 4, 6 should be 12, like that. Accept each and every value. So I decided to use the usual map method. Firstly, I am converting this to string. Okay? I am converting this complex to string. Right? Followed by I want to use the map method. Okay? And in the map method, I am saying that, hey map method, can you apply this transformation logic, which is what? Accept the input and do the I plus I dot for each. If it is not giving me the what we call it as suggestions, because it is an error, it is going to be a problem. System dot out dot println. Okay, the moment I do this, the compiler is not happy here. See, it is going to throw me an error. Why it is throwing me an error? See, look at the error. The operand, see, the operand plus is underdefined for the argument type s. So what is happening behind the scenes are, okay, let me take this code. Okay, let us try to what we divide and understand Okay, this is the data source. No explanation is required. Complex collection, you are dealing with what? Complex collection. Okay. And this complex collection is getting converted to what? Converted to a stream pipeline. Right? So this stream is going to have four simple collections: L1, L2, L3, L4. They are collection object again. They are not independent the wrapper class objects. Again, they are the collection objects. Isn't it? So you have L2 and L1. Okay. This is the, again, this is an object. What you are doing, you are accepting this object. Okay. This L1 is going to be, what is happening here? Okay. L1 is going to be accepted as I. Okay. And again, what you are doing, you are trying to perform a mathematical operation on this L1 object. L1 is not an integer. L1 is a collection object here. List of collection object. You are applying the mathematical operation. So don't you think that this is acceptable in the max? You can add two numbers. Can you add the? It is like adding. It is just like adding the collection object which we have 1, 2, 3 with 1. Okay, 1, 2, 3 plus 1. Nowhere it is related to the mathematical operation. Right? So ideally, what you want to do it here is, so this map method, so you know what is the purpose of map method. Map method always accept an input. Okay, it is going to do what? It is going to accept a function as an argument. Function f equal to, like, it can accept an input. So it is going to, again, the function is going to have the two parameters, right? So in this case, the object is what? The input is list of integer, right? Comma, the output should be the mathematically valued, right? So when I do this, I equal to I plus I, right? It is returning I equal to I plus I. It is accepting the list as an integer, and you're trying to add a kind of what? To list. Okay, so this is not how it is. So I have taken one here. Let us go with the one. So it is trying to, let me redo this, guys. Okay. So map is going to accept a function, and function, our function, I mean our map method, the input arguments are what? List of integers, comma, and the return type should be mathematically valid, right? Mathematically valid. If you are trying to, if you want to return the integer, because that is a requirement, right? You want to add the two numbers and you want to return it as the output should be what? Integer. But the problem here is the input is coming as the list of integer. It's not coming as an integer. It is coming as a list of integer. Output. So you want to think about the output, but the input is coming as a list of integers. Right? So how the input is coming? 1, 2, 3. What is our requirement? Each and every value should be transformed to another value. 1 should be transformed to 2, 2 should be transformed to 4, 3 should be transformed to 3. Right? So again, this is a collection. 1, 2, 3 is again a collection. Again, this collection, I can say that this is a source again. Again, this source needs to be converted to stream once again. You need to convert this source to the stream. Right? So this should be separated from the brackets. So you want to, because this is the L1 object, isn't it? 1, 2, 3 is what? L1 object. L1 is the collection again, a simple collection. You want to convert that to stream once again, so that after converting it to stream, you can perform any kind of mathematical operation. But here you are not doing that. You are directly, it is just like doing this, guys, without even converting it to stream. It is just like taking the collection object and applying the map method. Not possible, isn't it? Not accepted. Firstly, it needs to get converted to stream, then you can operate upon map. So when you encounter this kind of situation, when you are dealing with the complex collection, then the Java 8 people recognized this and they have introduced the method called flatMap. What is the method? flatMap. Right? So instead of using map, I can do what? I can use the flatMap. First, let us understand this. Instead of using map, I can use the flatMap. Right? My flatMap will accept a simple collection object. In this case, L1 will be accepted in the form of I. Right? You convert that L1 to stream once again. again you are converting that simple L1, okay, simple object to the stream, because L1 has again 3 integer objects, 1 2 3. You want to again break that to the stream once again. So here you are breaking the brick collection, here you are breaking the complex collection to the stream, but this stream has the 3 simple collections again, L1, L4 simple collections, L2, L3, L4, and again this needs to be broken to a simple what we call it as this simple collection needs to be broken to a stream again, converted to a stream again. That is the situation. You have to go for the flat map. Okay? Flat map is going to produce a stream of individual element. Then you can use the map method. Now this map method will able to get the output as the integer, right? And you can use the for each method and can do what, system.out.println, and you can print the values in the console. We will break this into pieces. I mean the logic. See, each and every independent value we are able to consume, and we are able to generate the required output. All the values are doubled. So let us understand this a little bit in a simple way. Okay, let me go back here, the paint screen, right? So let me put this here once again. Right, so I need some attention here. Okay, this is the program, right? So complex, again complex is a complex list of list integers, a complex collection. Okay, you have a complex collection, right? You are converting that complex collection to a stream. Okay, you are converting what? You are converting this complex collection to a stream. So when you do make some observation here, you are converting this to the stream, but the problem is in this stream has how many simple collections here? L1, L2, L3, L4. So this stream, okay, this complex stream has 4 simple collections, L1, L2, L3, and 4. They are of what type? List type. Okay. So it has, this stream has how many collection values? 4 simple collections values, L1, right? So now, so you are taking the using the flat map method. Flat map method. What they are saying is, flat map is going to, it is just going to behave like this. Okay, flat map behavior is going to be like, it is going to like accept the function as an argument, but the return type of the function should be always the stream of values. Return type of the function should always be what? Stream of values, right? So you accept the L1 object here, right? Okay. L1 object is accepted, and what you are doing with this L1 object, you are breaking this object into the stream. This is a simple collection object, right? You are breaking this object into the stream of values. Again, the stream of values. How many values are there in the L1 object? 1, 2, 3. 3 values, right? So you have the 3 values as a stream. L1, 1, 2, 3. Right? So for one value, okay, it is going to break that simple collection object into a stream. 1, 2, you are getting 1, 2, 3. Right? For one object, it is giving you what? It is giving you the arbitrary number of values as a output for one input value. Does it really mean? Flat map says when you pass function to a flat map, okay, for one input value, it could generate arbitrary means it is not what we call it as, it is not dependent upon the, I mean you cannot expect it, you cannot anticipate it. So it depends upon the number of values in the simple objects, arbitrary number of values or as the output. Okay, now pay attention here. For the simple L1 object, it is a collection. It is breaking that collection into the stream again, and you are getting 3 values, 1, 2, 3, which is of what type? And again, this whole thing is of what type? This whole thing is of what type? Stream type. Is going to produce the stream of values from the independent values. Stream of 1, 2, 3. Likewise, so there is a object called L2 object. I mean second L2, right? So this L2 will be accepted as an input, which is a simple collection, right? And it will be broken into the stream, right? So what are the values inside L2? 4, 2, 6. So how many values are getting generated for the corresponding input? For one input, it is going to generate 4, 2, 6. Okay? Stream of values. Okay? Like this, it is going to same things are going to happen for the remaining object, which is what? L3 and L4. L3 and L4. Same thing is going to happen. Right? So after this, again you are using the map method. Again you are using what? Again you are using the map method. This time map will do the actual transformation. What is the actual transformation? Doubling the number by plus I. Okay? Firstly, this 1 will be accepted, okay, transformed, and 2 will be accepted, transformed, 3 will be accepted, transformed, okay, and 4 will be accepted. Likewise, every element will be converted to stream by the flat map. That converted stream of values will be accepted by the map to generate the desired outputs. So don't you think that it is also performing the mapping as well as what? So this concept is as called, let me see. So when you see the input is 1 and there are many output values, so that's why they call it as what? One to many mapping occurs the flat map, right? So flat map is going to produce again. Flat map is going to produce again the stream of values, stream of simple objects. I mean, this data source, there are 4 simple data sources here. That needs to be converted to stream. Only when it is converted to stream, you can perform the desired operation, isn't it? Right? So flat map is also used for transformation and flattening. So flattening means nothing but, so go back to the code. So you have the elements like 1, 2, 3, 4. These are the values that you have. Right? What is the flattening? What does the flattening really means is, okay, these are the values that we have. 1, 2, 3, 4, 5, 6. I mean 4, 2, 6. 1, 1, 2. These are the values, actual values. Simple collections, right? Simple collections. Flattening means just breaking this from the collection source. So 1, 2, 3 flattened, right? 4, 2, 6. 4, 2, 6 flattened, right? Collection object is flattened. It is getting converted to a stream again, stream of values. 1, 1, 2 flattened, right? 5, 4, 6 flattened. 4, 6 flattened, right? So go back to the code and see. So flat map is going to accept a function. So I want to simplify this function. You pass the what you are passing here, list of integer object. A stream has list of independent simple integer object, right? And that needs to get converted to what? Stream of values. The return type should be what? Stream of integer again, right? And flattening. You're doing what? You're doing flattening. Accept the input as a simple array, convert that to the stream. Okay, so yeah, I need to import the function first. Yeah, done. So this is the argument of flat map. Okay, it is accepting the list of integer as an input, which is I, and it is producing the stream as an output. Again, this is a simple collection object. This needs to convert it to a stream. Again, you can treat this as each and every individual source, simple source, right? So instead of you can remove this, and you can also place this flattening reference variable name here. Same thing in a different way I'm showing. I just want to expand the function that you're using inside the flat map. So this is how you can expand the function. You can visualize the function which is accepting the list of integer as an input. Okay, each and every list is being passed as an input, and it is going to generate a stream. So accept the list and generate the stream. Again, after getting the stream, you can perform the map operations for the required transformation. Right. So we will see few more examples to understand this better. So this is one of the examples that we have. So there are some interview questions. So some one of the popular interview questions is like this. Okay, before even understanding about the interview question, I want to create a simple student object. I want to do what? I want to create a simple student object. Or else let me create a simple Java class object. So let us say that I am running a computer science institute. So in my institute, I have some list of students. I have what? I have list of students. Okay, the first batch of students. Okay, some students prefer to take Python list dot as list. So they are Ratna and so they prefer to take Python. Okay, and there is the second list of students who prefer to take Java, right? And they are like Shashwant and Srikant. Okay, and the third list of students who prefer to take a C language, C programming language, CP, right? And they are Samyukta and Darshini. So I have three list of students: Python, Java, and the C programming language. So I want to do what? I want to create a complex list here. So my complex list is going to accept the simple list as an argument as a generic type. List of string objects. So total students equal to what? I want to add the simple list into the complex list, which is what? Python again, Python, Java, and C. Right? Very straightforward. So now what I want to do? I want to flatten this. I want to extract each and every name. I want to flatten each and every name, and I want to create what? I want to concatenate each and every name with @gmail.com. I want to extract data from the simple collection, right? So I want to use this collection. I want to extract data from the simple collection, and I want to perform the concatenation operation by using Java 7. How you can proceed by using Java 7? So by using Java 7, this is how the code looks like. You are going to use the enhanced for loop. So enhanced for loop is going to be a nested enhanced for loop. List of string x inside students, right? Okay, you will take the list of students. You will iterate over the list of students, which is of what? Complex collection. Again, it has simple list like Python, Java, and C program. To extract the data from the simple list, right? You create another nested for loop, and this is of what? String type. This time you are doing what? You will extract each and every simple list which is inside this x, and you perform what? You perform the required operation. So our required operation is take the independent name and do the concatenation at the rate gmail.com. Okay, so when I run this code, I will be able to get the desired upload, which is what? Ratna@gmail.com, Jyoti Gmail, Sashwant, Srikant, right, Samyukta, and Darshini. I want to add the and symbol here, @ symbol here. Right. So this is one of the ways that we can do with the legacy Java 7. Till Java 7, this is so we can do till Java. I want to do the same thing with the Java 8. How we can do? So now you must focus here. So you must understand. You are dealing with what? You are dealing with complex list. So three independent simple list are again getting stored inside a complex list. First, this is the actual source. Okay, students are the actual source because students is of what? List of list type. Take the source, students. Not convert the source into the string. A pipeline will be created. Since you are dealing with the complex list, because this complex list has the three independent list, you need to use the flat map. You need to use the flat map because flat map is going to break this complex list and you will get the independent string values. Okay? Accept the complex list in the form of I, convert that to the string. Okay. So now each and every element will be taken away, extracted. Now first Ratna will come and you do the transformation. You apply the transformation logic here. Again, take the input as I and I dot concat of @gmail.com, right? Dot. You can use the for each method, and your for each method again will be accepting the input as I. Dot for each. Will accept the input as I, apply system.out.println because consumer, right? This is how the code looks like. So if you run this piece of code, you will get the desired result. Same result you will get. For the 2 times it is displaying because it is displaying this for the 1 time. Let me separate this for the understanding. Same output you are getting. I'll look at how many lines, only 1 line of code. So here you can see 2 lines because I have used the enter key for the better observation. But in this case, it is just like the code is you are using iterating it over and over again. This could be rewritten like this in Java 8. So this is the input of flatMap is just flattening the things. So let me do the visualization. File a new. All your doubts will be answered in this explanation. Stay focused. Okay. Now you see, guys, this is the actual. How many independent objects you have? You have the Python object, you have the Java object, followed by you have the C programming object. Okay, in the Python object there are 2 candidates, Ratna and Jyoti. Right, in the Java object there are again 2 candidates, Shashwant and you have the Srikanth. And in the C programming language you have 2 candidates, Samyukta and Darshan. Okay, my student's name, right? So Java object, Python object, Java object, and C programming object. So this part is done. This part is doing this behind the scenes. Memory allocation is happening behind the scenes, right? And this. So you are adding all this into a big collection. So this is a big collection. Right? So inside this big collection, you are storing the independent collection. Right? 3 objects are stored like this in the orderly fashion. Right? So this is a complex collection. Complex collection. The name of the complex collection is what? Students. So you want to convert this to stream. So converting the complex collection to the stream. Right? Stream is going to create a pipeline. Know this already. Stream is going to do what? Going to create a pipeline. So your pipeline is going to have the 3 simple collection objects. Yes or no? Yes or no? This is the first simple collection object, and you have the second simple collection object, right? And you have the third simple collection object. 3 simple collection objects are there. After this, you are using a specialized method called the flatMap method, which is used for transformation as well as what? Flatmap method. Your flatMap is going to accept the simple collection, first simple collection, right? Ratna, Jyoti, and it is going to convert the simple collection into the stream. Okay, Ratna dot Jyoti will get converted to stream because you are using the dot stream method inside this dot stream. Okay, now look at the transformation. Ratna and Jyoti is going to be as a single object, but the output is going to be like what? Transformation. After the transformation, the flattening, it gets output as Ratna and Jyoti. Right? For one object, you are getting 2 outputs, arbitrary values. Jyoti. Then you are collecting this Ratna inside the map method to do the actual processing. Map method is going to do what? Accept the Ratna and add the concatenation, which is what? Ratna at the rate gmail.com. And you are going to display these things in the console. Ratna at the rate gmail.com will get displayed in the console. Right? Idea is one simple collection. If you are dealing with a complex collection, always imagine or think about the flat map. So you need to separate the complex collection into the simple collection, and you need to use the stream method once again, and that can be achieved by using the flat map. Flattening, it is going to flatten the complete stream, right? And if you observe here, it is a stream of stream values, stream of streams. You need to convert the stream of streams to a stream again, right? So this is what happening by this. This is a typical example which you can practice. Right. So next example, and this example is going to be very interesting. So I want to create a student object. Right? Focus here. I don't think that flat maps are very easy. You can perform a lot of Java programs on top of this flat map. Trust me. I want to create a student object, guys. Students. So when you go out and visit any institute, so firstly they will ask your name, right? They will ask your name. So your names are mandatory. So I'm taking the name property. After asking your name, they would ask you the contact details. So some people, brilliant people, they have one contact number. Ordinary people, they have one contact number. The extraordinary people, they have many number of contact numbers, right? Phone numbers. Extraordinary persons. So they are going to collect the phone numbers in the form of string array. Right? So after doing this, this is okay. So this has come here. Okay. So these are the two properties. So I need to deal with these two properties, right? For that I am generating. I want to initialize the values to these properties. How to initialize the values to the instance variables? You need to deal with the constructors. So one constructor is going to do this, right? And I am also generating a constructor. I am also generating a toString method. Public source generate toString method to display the meaningful values in the console, and I am generating another toString method which is going to display only the phone numbers. Source generate string method. Oh, sorry, this is already there. I cannot generate two string methods. Okay, so this is the code. This is my code. Simple code, simple student class, and inside the student class I have a student constructor to initialize values, and I have what? I have overridden the toString method to display the meaningful message in the console. So now I want to add the student objects. Right? How I am supposed to add the student object? So let me create three student objects. Student 1, student. The first student is Ratna. All I can say that the first student is S1 equal to new student. So this new student, the first argument is what? The name of the student. Second argument is what? Array of phone numbers. Ratna is having 2 phone numbers. Let us say that. Because contact details are very so phone numbers are accepted in the form of array. So I'm using new string. Right? The first phone number is something like this. Second phone number is something like this. For the example sake. So 2 more student objects I want to create. So S2 here Jyoti, and she has 2 different phone numbers. The third one is Ramya. Yes, again 2 different phone numbers. So let us say that Ramya has 3 numbers. So 3 phone numbers. So I have 3 student objects. So these are the simple student objects, right? I want to do what? I want to add this to a collection. So list of student, right? inside the student list, I am adding all these individual students. Arrays dot as list you have h1 object, h2 object, and h3 object. 3 student objects I have. My requirement is I want to pick the student objects separately. I want to do what? I want to pick the student objects separately. I want to flatten this. So my requirement is I want to take each and every phone number. I want to send a message to the student as a kind of advertisement, as a kind of publishment, kind of publish that classes are going to start on so and so. So that is my actual requirement. And I want to collect all the phone numbers to another collection. I want to do what? I want to collect all the phone numbers to another collection. Right? So let me take the student object, students object dot, convert this to the stream dot, right? So the moment if I use the map method, look at what is happening. If I'm using the map method, if I want to get the phone numbers, array of phone numbers inside the map method, and collect collectors dot to list, right? So this map method is returning what? Let's see, I mean collectors dot to list. It should be this to list method. Okay. This map method is this map method is returning a string of phone numbers, string of contact details. Okay. So don't get any confusion. Sorry. List of string array. Yeah. So now don't get any confusion. See, let us grab this. Let us use the plain screen. Okay. So you are doing what? You have the data source students, which has 3 student objects, S1, S2, S3. The pipeline will happen, right? S3, S2, S1. 3 student objects are there. And what you are doing, you are taking each and every student object. S1 will go inside the map, and you are extracting only the phone numbers, I dot phone numbers, right? So it is going to return every time. It is going to return an array. S1 is going to return what? It is going to return array of elements. Array of what? Array of elements. S1 will return these values, right? S1 is going to return the array of values. You are extracting phone numbers, but there are 2 phone numbers for us now. So 2 phone numbers will be extracted. Okay, and these phone numbers is collected to the list. Collected to what? Collected to the list. To list. You are using to list method. Okay, and the generic type is what? The string type, string array type. The generic type is what? String array type. At the moment you display this in the console, the moment you system.out.println contact details, right? And if you run this code, you will get a kind of weird value, garbage value. See, so you need to override the toString method here, because each and every value is of array type, string array type. So toString method is not overridden successfully here, right? So in order to extract this value, you cannot do this. In order to extract each and every value independently, again you need to run a for loop. For loop is of for string array type x inside contact details. Nested for loop, right? After fetching, it is going to return an array, and after getting that array, you need to do what? You need to extract the string values of each and every array, each and every value inside x. So nested for loop. See? A inside x. Okay, if you print this system.out.println, and if you try to print a, so each and every value will be displayed on the console. Right, so this is how you do that. Okay, so when you're doing the map method, it is just like it is not exactly, it is not performing the flattening. You want to collect these values as a string itself. You want to collect this value as a list of string, not list of string array. Please focus here. When you're using map method, you're able to collect all the elements as the list of string array. But you want to do what? You want to collect it like list of string itself. You need to remove that array barrier. You need to remove this array barrier. But how you can achieve this? You can go for flat. Instead of using map here, use the flat map. It will take care of the flattening. Right? It will take care of the flattening. Let me remove this. It's going to take care of what? Flattening. Context. Flat. I want to use a flat map. Right? So instead of map here, I am using what? Flat map. So my flat map will convert each and every array. So when you want to convert, it is going to accept the input as the array, right? So arrays dot stream I dot phone numbers. You will use an arrays dot stream method, right? It is going to accept the phone number, and that array of strings. That array of strings will get again converted to what? The array of strings is going to get converted to the flat map. I mean, it is going to conversion is going to happen for the flattening purpose, right? So after doing this, just use the map method for the transformation. Just use the map method for the transformation and store this into the list of string. The contact details after flattening. Contact details flatten, something like this. Okay, now if you print the system.out.println contact details, if you get logged out of the meeting, please rejoin. One more program is there. Contact details. If you run this code, so I need to print this contact details flatten. This one I need to print, right? If you run this piece of code, all the phone numbers are flattened now. All the phone numbers are flattened. Very simple. You don't need to think much. So just think that when you are dealing up with the complex collections, okay, simple collections, no issues. You're even dealing with a complex collection object, just like this. So this is also a simple collection, but there is an object inside which is of what? Array type, right? This is also typically simple collection, right? So you are using the student as a source, converting it to the stream, and you are using the flat map, right? Flat map will accept each and every student object. So to say that flat map is accepting S1, but when you see this S1 as name as well as S1 as phone numbers. Phone numbers is of what type? Array type, right? Array of phone numbers, right? And what you want to accept, you accept this is going as an object. This is going as an object as I. Right? You are extracting the phone numbers only, I dot phone number, and you are passing that to arrays dot stream, which is going to convert each and every phone number into a string. It is going to produce two phone numbers. It is going to produce how many phone numbers? Two phone numbers, because ideally the phone numbers are in the form of array, right? The first phone number is in the form of array. So this will be taken as an input by the flat map. It is going to generate it is going to flatten this. So for each and every input, it is going to flatten this input, and two outputs will be generated after flattening, after transformation. So after doing this, as soon as you do this flattening, you are using the map method. This map method will directly print the values. I mean, it will going to directly take each and every values, and it will be collected in the form of list. Right? So this is how it works. So this is one of the examples where you can actually think about the flat map. Right? So there are few more examples which I will give you, so you can practice this. Right? Plus practice these three problems. Then if you have any doubts, you can ask me. Thank you so much for your time. Have a good day.